Hello, my name is Francisco Calderon. I am the director of CBARC.
I am Stephen Machado. I am agronomist at CBARC.
Today we're going to talk about soil quality and grain yields under different residue managements. It's a new data set that was collected this spring, and it includes also yield data from the 2 previous years.
CBARC is the home to the oldest long-term experiments in the Western United States. We carry out long-term research to guide us in the development of sustainable agriculture. We identify the effects of crop rotation, fertilizer use, soil amendments, varietal development on soil health and productivity. Some of these changes in soil properties, they take years to show after you change management practice, in the order of 10 to 20 years. Changes in soil microbes, microbial communities, maybe from 2 to 8 years to change, to show an equilibrium in a new system. So we conduct these long-term experiments to identify the interactions between plant, water, and soil. And this information is important for both agronomic and agricultural policy development.
At CBARC, we have a collection of long-term experiments, some of them dating back to the 1930s. And they include different treatments. Things like a long-term grass pasture that is kind of a baseline of what a good soil pre-agriculture could have been. We have a continuous cereal experiment testing yearly fertility and tillage on continuous crops. We have a residue management experiment, which is, by the way, the one that I'm going to be talking about today, which tests nitrogen, manure, and P-vine additions, as well as residue burning. Then we also have a tillage fertility experiment that dates back from the 1940s that has different nitrogen treatments. We also have a wheat pea experiment that tests the inclusion of pea in the winter wheat rotations. And then we also have a no-till wheat experiment dating back to the 1980s, which tests the effect of different nitrogen rates.
When they started these experiments, that was the time when the nitrogen was coming in. So they wanted to determine the rates, the optimum rate of nitrogen for the winter wheat. So that didn't take 3 years, 4 years. They already knew it was around 80 or 100 pounds per acre. But then some wise scientists decided to continue the experiment. And as the years passed, the more the nitrogen you put, the more the soil became acidic. So that we would not have known if we did not continue the long-term plots. That if you use too much nitrogen, you might end up with an acidic soil. So that is one of the values of this long-term plots.
Crop residue management long-term experiment. This experiment has started in 1931 and includes several wheat straw management treatments, residue kept, incorporated, or burned. And there's 2 burn times. One is in the fall and one is in the springs. There are also, in combination, 3 nitrogen rates, and nothing nitrogen added control, 40 pounds and 80 pounds of nitrogen. There's also a manure treatment of 10 US tons per acre, or a P-vine added amendment treatment of 1 US ton per acre. All of this happens in a wheat fallow rotation, and the experiment is split so that there's 1 block that's in crop and 1 block that is in the fallow every year. So the measurements include 2 measures of soil health and 2 measures of crop health, as well as grain yields. We are including the grain yields from the last 2 harvests, 2019 and 2020. And we also have the 2 soil health measures. One is bulk soil electrical conductivity, which was collected using Tindleman reflectometry, TDR probe. We also have penetrometer resistance, and then the two crop health treatments are NDVI and NDRE, and these are long-term normalized difference vegetation index and normalized difference red edge index. And basically these are reflectance measurements of several points in the visible and near infrared spectrum in different combinations, and they tell us about the health of the growing crop. It is thought that the NDRE is more appropriate for later stages in crop development, but they are both included here. Slide number 7 is a picture of one of the fall burn plots, and as you can see, all the residue has been burned, and all that is left as the return to soil is the charred wheat straw going into the soil. So in slide number 8, it's a picture of the long-term crop residue management experiment looking east from the west end. So you can see the Blue Mountains at the distance, and this picture was taken early this spring at the time that we took the TDR electrical conductivity measurements. Slide number 9 shows us a picture just cut out from Google Earth, and it's really illustrative because it shows the north end of the plots in fallow and the south end of the plots in crop. And the nice thing is that if you look at it carefully, it does show the darker rectangles, which are the manure treatments. So they are way ahead of the rest of the treatments. This must have been taken sometime in late winter or early spring, where you could see that some plots had germinated more strongly than others. So in this slide, we're showing the grain yields for the 9 different treatments in these long-term plots. And the first thing that stands out is that the manure treatment did so much better than the rest of the treatments in terms of grain yields, both in 2019, which had a little bit above average precip, and 2020, which had a little bit below average precip. If you look at the rest of the treatments, you do see how the no nitrogen added treatments tended to yield low. No surprise there. The lowest yielding treatment in both years is the fall burn no nitrogen added treatment, for example. Now, one interesting thing to observe is that there's not a clear benefit in terms of yields between the 80 pounds of nitrogen and the 40 pounds of nitrogen. And that was true also for both 2019 and 2020. In this slide, we show the NDVI readings for all the treatments. And here you also see something very interesting, and it's that NDVI, it is a sensitive measure of plant health, and you can tell differences between the 80 pounds of nitrogen and the 40 pounds of nitrogen that you did not see in the grain yields necessarily. So that's an interesting thing to think about, whether you know, the 80 pound nitrogen is resulting on healthier wheat, but then that doesn't necessarily translate to higher grain yields. Now keep in mind that this is a comparison of current NDVI with previous year's NDVI. So there's that to take into consideration. Again, the manure treatment has the highest NDVI, so that corresponds with what we saw with the grain yields, and also the P-vine treatment has pretty high NDVI comparable to the 80 pounds of nitrogen treatment. So this slide shows the NDVI data in a different way now. So we are comparing the NDVI on the x-axis with the crop yields from 2019 in the y-axis. And what it shows is that the relationship between current year NDVI and previous year's yields, it's not linear. So for example, the manure yield response is much more stronger than what you would think looking at the NDVI data, or what the NDVI would indicate. One interesting thing though is it does show that there's a slight increase in the intermediate nitrogen treatments, the 40 pounds and 80 pounds, compared to the 0 N added in terms of the relationship between NDVI and crop yields. So long story short, the relationship between current year NDVI and previous year's yields is nonlinear, so that complicates the interpretation slightly. This slide shows the electrical conductivity as measured with the TDR probe in relationship to previous year yields. So we have the comparison for the 2019 yields and the 2020 yields. So remember that this is a soil measurement, so we could get TDR readings both from the fallow plots as from the crop growth plots, and that's what we're showing here. The figure does illustrate very clearly that electrical conductivity does not really have any sensitivity between nitrogen rates. It's a scatter plot. What it does show is that the electrical conductivity is higher on the manure plots. And of course, we already mentioned that the manure plots have some of the higher yields. So that pans out from the electrical conductivity. But again, no resolution between the residue burn or residue kept or the nitrogen rates with the electrical conductivity meter. Last piece of data that we're going to show is the penetrometer resistance, and to me this one might be one of the more interesting graphs from the presentation, because it shows how organic amendments are a good way to improve the soil compaction conditions and the soil structure. If you see from these lines, both in the fallow plots and in the wheat growth plots, there's a higher penetrometer resistance starting in about 6 inches down to 12 inches. There's a hard layer there. The interesting thing is that the plots that receive either manure or pea vines have less compaction at that layer. So remember, this is a long-term plot, so this has happened over years and decades, and it's showing that one good way to improve your soil tilth and soil physical condition is to add organic amendment. To recap, in terms of yield effects from 2018 to 2020, fall burning and no nitrogen added control had the lowest yields. No surprises there. The manure treatment had the highest yields on the 2 harvests within those years, and the 80 pounds of nitrogen did not always outyield the 40 pounds of nitrogen in this experiment. And I did not show that data, but the 80 pounds did have higher grain protein in 2 out of the last 4 years. There was no large effect from the residue burning versus the residue kept on grain yields. And pea vines had an inconsistent effect on yields, although it was always higher than the 0 nitrogen control, but lower than the manure treatment. So it's doing something, it's just not showing a clear effect in that regard. To conclude, the data from this spring, NDVI and NDRE are both sensitive indicators of treatment effects, but the relationship is non-linear when you compare that to grain yields. These 2 indicators are potentially valuable because much like the penetrometer resistance and the EC, these are things that you can go to the field, collect the data, and come back to your office with the data. So there's no laboratory work involved. Bulk electrical conductivity was not very sensitive to nitrogen rates or residue treatments. It was sensitive to manure additions, possibly because of all the minerals and salts that are added with the manure, which increase or alter the electrical conductivity of the soil. And penetrometer resistance readings were really illustrative about how organic amendments, pea vines and manure in this case, are mitigating soil compaction in these soils. That's all I have. Thank you very much.